Section 3.1 is on reference angles. Reference angles are also called related angles for any angle theta in standard position, meaning that it starts at the positive x-axis and goes counterclockwise, is the positive acute angle between the terminal side of theta and the x-axis. So that could be the positive or the negative x-axis. And in this book, you are going to see the reference angle for theta represented by theta with a little caret key above it, and that means reference angle. So let's go over some examples of what that looks like. We are going to name the reference angles for each of the following. So we're going to start by drawing our picture because that's usually very helpful for us to find that reference angle. In this one, we have an angle of 30 degrees. So our reference angle is going to be between that terminal side of the angle and the x-axis that's closest. So it's either going to be the positive or negative. So in this case, our reference angle is also going to be 30 degrees. If we look at our next example, and if we draw our picture of our angle, 135 would be over in the second quadrant. And we know that this angle is 135 degrees. To find our reference angle, we need to find between the terminal side and the x-axis what that angle is going to be. So that's going to be our reference angle. So to do that, we're going to take 180 for this one, and we're going to subtract the angle we know, which is 135. And by doing that, we're going to get that leftover angle, which is our reference angle in this example, which is going to be 45 degrees. So in our example B, reference angle is 45 degrees. Our next one, we have the angle of 240. So 240 is going to end up being in our third quadrant. So all the way around for this one would be 240 degrees. And we need to figure out what just this angle is, theta, with our reference. So for this one, we know all the way to the end of the second quadrant is 180 degrees, and we need to figure out that reference angle. So this time we're going to start with our original angle, and then we're going to subtract 180 to figure out that difference, which will give us that reference angle. So this would end up being 60 degrees. And our last example for reference angles is going to be 330 degrees. And if you draw this one, you're going to end up in the fourth quadrant. And that's going all the way around for 330 degrees. And our reference angle is going from the positive x-axis this time. So we're going to take the 360, which is what we know the full circle is, and we're going to subtract the angle we know of 330. And that's where we're going to get the reference angle of 30 degrees. Now, the reason these reference angles are important is because you'll notice it gives us our two special right triangles angle measurements. So it gives us 30, 45, 60, 30 again. Those are all values where we can get exact answers for our trig ratios. So a lot of times these reference angles are going to help us evaluate bigger angles in a way that we can use our special right triangles. So our reference angle theorem is a trigonometric function of an angle and its reference angle differ at most in sign. So the only thing that could be different about them is their sign. So you could have positive 1/2 or negative 1/2. For this example, we are going to find all angles between 0 and 360 that have a reference angle of 30. So that would be in the first quadrant right here. We would have a reference angle of 30. In our second quadrant, we would have this angle over here. We know that angle is 30. Third quadrant, 30. And then our fourth quadrant, 30. So we just need to figure out what all four of those angles are. We already know the first one. And then to get to the second one, we're going to take 180 minus 30, which would be 150. Our third one, we would take 180 plus 30, which would be 210. And then our last one, we are going to have 330. So these are all of the angles that have a reference angle of 30 degrees between 0 and 360. So if we were to evaluate sine of all four of these angles, it would have the same number value. The only thing that would be different is the sine. So we know the sine of 30 degrees equals positive 1/2. We know sine in the second quadrant is negative. Oh wait, also positive. So that would also be positive 1/2. And then sine in the third and fourth quadrant is negative. So that means the sine of 210 is negative 1/2. And the sine of 330 is also negative 1/2. And you can check that on a calculator, but you'll notice that they're the same number, just different signs. And that's what our reference angles help us determine. So example 2, we're going to find the exact value of sine 240 degrees. So the first thing you're going to do is draw a picture of your angle. So this one we have 240, which would be in the third quadrant. Step 2, you're going to find your reference angle, which we represent with theta with a little caret above it. So in this one, we're going to take 240 minus 180, and that will give us our reference angle of 60 degrees. So we know that's 60 degrees. Then step 3, you are going to draw your right triangle, which I've already done here. And step 4, we are going to evaluate. So with our right triangle, we're going to label the sides with the information we know. So we know that this angle down here is 60 degrees. So opposite of the 60 degrees is the square root of 3. But we are going down, so we're going to use negative square root of 3. We know the hypotenuse is 2. And then the other leg is going to be 1. But we're going to the left on the y-axis, so that would be negative 1. So now we're going to find the sine of 240 degrees. So using the reference angle of 60, we would get sine of being negative square root of 3 over 2, which is our exact value. Now, let's follow those same steps to do number 3. So we're going to start by drawing our picture, and this one is 315 going around. Then we're going to find our reference angle. So this one, to find that, we're going to take 360 minus 315, and we're going to end up with 45 degrees. Then we are going to draw our right triangle and label our sides. So the sides we use for 45, 45, 90 is 1, 1, and square root of 2. Because this 1 on our dotted leg is going down, that would be a negative 1. Then for step 4, we are going to evaluate. So for this one, we're finding the tangent of 315 degrees. So tangent from this angle of 45 is negative 1 over 1, which just equals -1. All right, so if you want to try to do examples 4 and 5 on your own and then hit play to check your answers, you can do that to see how well you understand this concept. All right, so I'm going to start by drawing my angle, my picture, which is 300 degrees. Finding our reference angle, which in this one would be 60, because 360 minus 300 is 60. Then we can draw our right triangle, and opposite of 60 is the square root of 3, which this case it'll be negative. And this time we are finding the cosecant of 300 degrees. So cosecant is going to be our hypotenuse over the opposite side. So this one would be 2 over negative square root of 3. For these, you are going to want to make sure you rationalize your answer. So we're going to multiply the top and the bottom by the square root of 3 to get our final answer of 2 square roots of 3 over 3. And it's okay to just pull that negative sign to the front of your fraction. So the overall answer would be negative. Okay, our next example 5. We're going to find the exact value of cosine of 495 degrees. So off the top of my head, I have no idea what quadrant that is. So I am going to figure out a coterminal angle with that by subtracting 360 degrees. That gives me 135 degrees. So we know that this is going to end in the second quadrant. And we're going to go around one full time and then end at 135. And that tells us we went 495 degrees. Then we need to find our reference angle here. Because I know just from the positive axis to that terminal side is just 135 degrees, I'm going to use that to figure out my reference angle. So for this one, 7, 10, 5, we're going to end up with 45 degrees. Now that we have our reference angle, we can again fill in our triangles. Don't forget to add in the negatives when you're going a negative direction. So for this one, the bottom one should be negative. Now we can evaluate the cosine of 495 degrees, which is equal to the adjacent over the hypotenuse. So our final answer will be negative square root of 2 over 2. And that is our answer. All right. So for the next part on this, you are going to need a calculator. So for example 6, we are going to find the angle theta if sine equals negative 0.5592. So we know sine is negative in quadrant 3 and quadrant 4. So we are just going to remember that. So what we are going to do is we're going to be finding our reference angle. And to find our reference angle, we are going to do the same thing that we did before by typing this into our calculator using the inverse functions. The only thing different that we are going to do is we are not going to include the negative. So on here, when you type it in the calculator, do not type the negative. So in your calculator, you are just going to type the inverse sine of 0.5592. And by doing that, this is going to tell us what our reference angle is. The negative sign, because we don't include that, we still need that information, but that tells us what quadrant it is in. So that's why we don't type it into our calculators, because we're just going to get our reference angle by typing in the positive value, and then the negative just tells us what quadrant it'll be in. So you're going to want to go ahead and grab a calculator, and then we type this into our calculator to get that value. And this is 0.5592. So this is about an angle of 34 degrees. So that's our reference angle. They wanted us to find theta, which terminates in quadrant 3. At this point, it might be helpful if you draw a picture to help you visualize what you need to do to find theta. We know that this is going to be in quadrant 3 down here, and we know our reference angle is 34 degrees. So to figure out what theta equals, we're going to take 180 plus 34, and that will tell us what our total angle is for theta. Which will be 214 degrees. All right, moving on to our next example. For this one, again, we are going to be finding theta to the nearest tenth of a degree if tangent theta equals negative 0.8541 and it terminates in quadrant 4. So let's start. I'm going to draw a picture just so I know that this terminates in quadrant 4. And we need to figure out what that reference angle is. To do that, again, we are going to use our inverse tangent. And we are going to just do 0.8541 because remember, we do not include that negative sign when we type it into our calculator. 0.8541. So this gives us that our reference angle is about equal to 40.5 degrees. So to figure out what theta equals, for this example, we are going to take 360 minus 45.5. And that tells us what theta is, 314.5 degrees. Okay. So we just have 3 more examples of these. If you feel pretty confident, you can probably skip these examples for the notes, but if you would like to go over a few more together, you can continue to watch the video. All right, so example 8, again, we are going to do sine of theta equals negative 1/2, and theta terminates in quadrant 3. If we were to find our reference angle, we would type into our calculator the inverse sine of negative 1/2, and that will tell us our reference angle. Oh, and I'm sorry, I forgot. You do not include that negative sign, just 1/2. And this reference angle is going to be 30 degrees, which makes sense because we know the sine of 30 degrees is 1/2. So to figure out what just theta is, we're going to take 180 plus 30, which which will give us 210 degrees for our answer. Our next example, again, we're finding theta for secant and terminates in quadrant 4. We'll go to this one. We know it terminates in quadrant 4 down here, and we need to figure out that reference angle. For this one, we're doing it the same way we did last chapter, where we have secant, so we're going to still use inverse cosine. And then in our calculator, we're going to type 1 over that 3.8637. And that will give us our reference angle. So it's very similar to what we did last chapter. We just remember, do not include the negatives. And this one would be, if we rounded it, 75 degrees about. And because this is in quadrant 4, to figure out theta, we're going to take 360 minus 75, and that will equal 285 degrees. Our last example, we are doing cotangent. So for this one, we're going to draw our picture, and they said cotangent terminates in quadrant 2. And we are looking for the reference angle to start with. To figure out our reference angle for cotangent, we're going to use the inverse tangent function and then just type 1 over 1.6003. Remember, we do not include that negative sign when we type it into our calculators. Inverse tangent of 1 divided by 1.6003. And this one, we're going to get about 32 degrees. And because theta is in the second quadrant, we're going to take 180 minus that reference angle to get our answer, which would be 148 degrees. All right. So below is the homework assignment. You'll notice when you look on the answer key, there are more problems than what are assigned. The original assignment was pretty long, so I shortened it down some. So you're only doing the odd numbers. So make sure when you're checking your answers, you're looking at the correct problems. If you have any questions, just let me know, and have a good day.